Lesson on functions. Functions. The essential understanding for this lesson is that the value of one variable may be uniquely determined by the value of another variable. Such relationships can be represented using tables, equations, words, sets of ordered pairs, mapping diagrams, and graphs. We see a picture here of something that you've probably seen in math classes before, and this is a graph of a function with a related table. A table of values can represent a function. It has a column for the x values or the inputs and a column for the y values or the outputs. Another way to look at a function is by looking at a set of ordered pairs with x and y values separated by commas in parentheses. A third way to look at a function is using a mapping diagram. A mapping diagram consists of two ovals. The inputs are on the left, the outputs are on the right. Each input is mapped to an output. The line from each input to each output represents one set of ordered pairs. Another way to look at a function is through the use of an equation. You've seen equations such as y equals 3x plus 4. Another way to look at a function is f of x equals 3x plus 4. F of x is just the output of the function or the function of x. The f parentheses x end parentheses is read f of x. We have some vocabulary related to functions. We have our input, our x values, which are also called a domain. Domain is just another name for the input to a function. We also have the output, or the y values, and another way of looking at is called the range. So often when we look at functions, we refer to the domain of the function and the range of the function. The domain, again, is the set of all input values. The range is the set of all output values. And as you can see here, the domain is on the left, the range is on the right. Each element in a domain is mapped to an element in the range. Some more vocabulary related to functions. A relation. A relation is kind of like a function, but it's not a function. It's just a set of ordered pairs. Again, you can have a relation that has a mapping diagram, but the difference between this relation and a function is that the input of 1 has two outputs, A and B, and the input of 3 has two outputs of A and C. Again, a function is uniquely identified as one input has one unique output. Relations can also be represented by a set of order pairs, just like a function can. Again, relation that's shown here, we have two inputs of 1, but each of those inputs has a different output. I also have two inputs of 5, and each of those inputs has a different output. And if we look at a graphical representation of that relation, we can see that the input of 1 has two dots above it, or two outputs, and the input of 5 also has two outputs. So we have some more vocabulary, and we're looking at the function, what a function is. Function is a relation. However, the difference between a function and a relation is that in a function, each input is paired with only one output. So we have a graph here, which is similar to the graph that we saw on the previous slide. The difference is that the input of 1 only has one output, and that output is 1. The input of 5 only has one output, and again, that output is 5. You can think of a function as a machine. You put something into it, the input. There is a rule that manipulates whatever you put into that function, and a unique item comes out of that function machine. Again, here are some examples of functions and non-functions. This set of ordered pairs is the first example of a way of modeling a function. Again, every input is unique. We have an input of 4, 5, 6, 7, and 8. There are no repeats there. However, we can have a relation that's not a function, and we have some repeating inputs. The input of 4 has an output of 12. The input of 4 also has an output of 15, which makes this not a function. Another way to look at a function is through that table of values, where you have your inputs or your x values or your domain, and your outputs, your y values or your range. The inputs or the x values are all unique. There are no repetitions. The inputs are 1, 2, 3, 4, 5, and 6. So there's no duplication on the inputs, which makes this a function. The outputs doesn't matter whether there's any repetition. However, we have a relation in a table of values, and if you take a look closely at the inputs, we have an input of 1, which is an output of 2, and then in the third box down, there's an input of 1, but that one has a different output, which makes it not a function. So let's look at some more examples. We have another table of values, but this one is horizontal instead of vertical like the previous one. We have our x values, our inputs, and our y values in the function. Our x values in the function on the left, none of them are repeating. We have -3, 0, 3, 8, and -10. However, on the right-hand side of the page, we have an input of -2 with an output of 6 and another input of -2 with an output of 20, which makes this not a function. Another way of looking at functions and relations are using mapping diagrams. We have a mapping diagram with a domain that includes the values on the left, 10, 3, 4, 7, and 5. Each of those input values on the left, or those domain values, are only mapped to one output value. Each one has a unique output. On the right, we have a mapping diagram that is not a function, and what makes it not a function is that the input of 5 has an output of 4 and an output of 7. So that is not a function. In summary, a function takes one input it does something to it, and it provides an output. And every input has its own unique output. That's the end of the lesson for today. It's hopefully helpful. And if you have any questions, please let me know.